So today we're going to be talking about multiplying and dividing rational expressions. Now before we can get into that, we are going to talk about simplifying rational expressions. So we're going to be starting with a fraction that has polynomials. We're going to first try to factor anything we can in the numerator or denominator. So here's a worked out example, because our goal is to simplify this into as little bits as possible, so the smallest terms as possible. So here's our starting fraction. So I see that the top, I have x squared plus 4x plus 3. So we can factor this. Remember, we're looking for two numbers that add up to 4 and multiply to 3. So I know that would be x plus 3 and x plus 1. So if I multiply 3 times 1, I'll get 3. 3 plus 1 will give me 4. So that's how this gets placed here. All right, so we replaced this trinomial with its factored form. All right, we still have the 5x out front. Then in the denominator, we did the same kind of thing. So we left the x minus 6. But remember, this is a difference of squares. So we have x squared minus 9 can be rewritten as x plus 3 times x minus 3. And that's how we end up with this piece here. So now we're looking for anything that can cancel each other out, so to speak, because we know anything over itself is 1. So I see that on the top and bottom, I have x plus 3. So I'm going to cancel those out, all right, because they reduce to 1. So I have 5x times x plus 1 on the numerator, and the denominator I'm still left with x minus 6 times x minus 3. And that's going to be my final answer. So this is its most simplified form. Now, what we're going to do next is we're going to look to see where this expression is undefined. This is something that'll come more into play when we get into our graphing piece in a couple of lessons. So what we're looking at here is to see where our fraction is undefined. Now, if you think about it, when we have a 0 in the denominator, that means that our fraction is undefined. So we're looking for any possible numbers that could be values of x that would create a 0 value in the denominator and make this undefined. So we're going to take a look at our most factored form of the original denominator. So this was our original denominator, but remember we factored this out into x plus 3 and x minus 3. So we're going to take all three of our factors and we're going to set them equal to 0 and solve for x. So that will give us the three numbers that will create an undefined value here. So just an example. So we have x minus 6, we're going to set that equal to 0, x plus 3 equals 0, and x minus 3 equals 0. All right, and then we just do the algebra to get the x by itself. So that will leave me with x equals 6, x equals negative 3, and x equals 3. So these are the three places, the three values that would make this expression undefined. Okay, so with this next problem, we're going to look to try to simplify this in any way we can, and then we're going to look at the places where it would be undefined. So again, the first place we want to start is we want to try to factor the numerator or denominator wherever we can. So we're trying to get things to cancel out. So I see the top is as factored as can be, but the bottom, I have this y squared minus 9, so that difference of squares. So remember, we can rewrite this as y plus 3 times y minus 3. All right, and that's again our difference of squares, that a squared minus b squared format leaves us with a plus b times a minus b. All right, so that means that our expression will be 3y times y plus 7 over y plus 7 times y plus 3 times y minus 3. All right, now I see I have y plus 7 in both the numerator and the denominator. So we can simplify that out. So that leaves us with 3y in our numerator and y plus 3 times y minus 3 in the denominator. So that's our simplified form. And now we're going to see where this expression will be undefined. So again, we look back to the original denominator in its most factored form. And we're going to take each of these factors and set them equal to 0. So I have y plus 7 equals 0, y plus 3 equals 0, and y minus 3 equals 0. All right, and again, I'm getting my variable by itself. So I have y equals negative 7, y equals negative 3, and y equals 3. So in y is either of these three values, our expression is undefined, meaning we get a denominator that's 0. All right, we're going to do the same over here. Now I see that the denominator is as factored as can be, but it's this numerator. We have the z squared plus 2z minus 8 that we can factor. So we're going to look for two numbers that add up to 2 and multiply to negative 8. And that will be z minus 2 times z plus 4. All right, so I'm going to rewrite this. So I have 2z times z plus 5 times, now I'm going to rewrite this in there, z minus 2 times z plus 4 all over. Nothing's changed in the denominator here. Z minus 1 times z plus 5 times z minus 2. All right, and again, I'm looking for things that match up. I want to cancel as much out of this as possible. So I see that I have z plus 5 in both the numerator and denominator. I also see that I have z minus 2 in the numerator and denominator. All right, so I can cancel those out. And that leaves me with 2z times z plus 4 in the numerator over z minus 1 in the denominator. All right, so that's our simplified form. Nothing more you need to do here. We're not going to multiply back through. We're just going to leave it as is. So now we're going to look at our original denominator, and we're going to find where this expression would be undefined. So again, I'm going to take each of these factors, set them equal to 0, and solve for z. So I have z equals 1. So our expression is undefined at z equals 1, at z equals negative 5, and at z equals 2. All right, so the last little piece of simplifying that we're going to talk about is using negative 1. So we can factor out a negative 1 out of a term, a set of terms, a set of parentheses, in order to change the signs to make things cancel out in the top and bottom. Oops. So if we look at this example here. So we're given this expression. Now, we first want to check to see if there's anything we can factor. Can we factor out a greatest common factor even, or factoring like we've been doing with the difference of squares or a trinomial? So you see in this first term here, we can factor out greatest common factor of w. So that's how the top ends up as w times 4w minus 3y. Then we still have the w plus y. Then in the denominator, nothing's changed, so left that alone. But what you can see is that we are so close to getting these two pieces to cancel out. All right, one is 4w minus 3y, one is 3y minus 4w. So it's just the signs that are different. The order is written different as well. I'm going to take the numerator and I'm going to rewrite that in the y order first, so it matches what we have in the denominator. You don't need to do this step, but I just want to show you where this is coming from. So in the top, I'm going to change this order to negative 3y plus 4w. All right, so that's this factor here. I'm just zoning in on this for a second. So now this matches pretty closely to the 3y minus 4w. The only difference is that the signs are opposite. So if we factor out in this top term here, if we factor out a negative 1, all that does is change the signs of both of the terms that we're multiplying it with. So this would then be something that could cancel out. Now I still have this negative 1 here, so we still have to take that into account in the numerator. All right, and we can just multiply that by the w, make it a negative w just to clean it up. So You'll see the explanation here as well. So we had 4w minus 3y, and when we factor out that negative 1, it turns into a positive 3y minus 4w. The order in which these terms are written really does not matter to me. If it's easier for you to write things in the same order, that's great. Do that. So we multiplied the negative 1 times the w, so I get negative w. We still have w plus y on the top, and on the bottom we have 5w plus y. And that's our simplified form. So we're going to look at this again here. So we want to see if there's a greatest common factor. So I see that I have a to the fourth in both of these terms in the numerator. So I'm going to factor out an a to the fourth. That leaves me with b minus 2. All right, in the denominator, I see I have a to the third here that I can factor out. So a to the third leaves me with 2 minus b. All right, now again, we see that these pieces right here, b minus 2 and 2 minus b, they're pretty similar. I'm going to go ahead and rewrite this. So I have a to the fourth times b minus 2 over a to the third times, I'm going to just switch the order, so I have negative b plus 2. So now what I want you to see is that if we factor out a negative 1 here, that'll change our signs, leaving us with b minus 2 over b minus 2, and those will cancel. All right, so I have a to the fourth over of negative 1 here, okay, times that a to the third. So I can just write that as negative a to the third. All right, now let's remember our exponent rules. So when we have the same base on the top and bottom, remember we can subtract the exponents. So the 4 minus 3 would give us an exponent of 1. Now to remind you where this comes from, this can be rewritten as a times a times a times a over a times a times a. All right, we still have that negative out front. But remember, a to the fourth is just a times itself 4 times. A to the third is a times itself 3 times. So these 3 sets will cancel out, leaving us with just 1a. We still have the negative out front, so we end up with negative a. That's what this whole thing simplifies down to. All right, so again, what I did here, you don't have to draw out all the letters. I took my exponents and subtracted them. So I had a to the, I have that negative up front, 4 minus 3, which will give me 1. So that's why I got negative a to the first power, which we don't really need that exponent of 1. All right, and lastly here, we're going to do the same thing, see if there's anything we can factor out in the top or bottom. So in the numerator here, I see that I can factor out the z from both terms. So greatest common factor, so I get x minus 4 in my parentheses here. I have z squared on the bottom, and then 4 minus x. All right, let's rewrite this so that I have the same order. So I'm going to rewrite the bottom. I like to have the variable first. It really doesn't matter which one you rewrite. So I'm going to rewrite this. So I have z times x minus 4 over z squared times negative x plus 4. All right, so again, I just swapped the order in which these were written. So now what I'm going to do is I'm going to factor out that negative 1 out of this right here. So that'll leave me with z times x minus 4 is our numerator, and then I have z squared times a negative 1 that we factored out, and that changes our signs to a positive x and a negative 4 here. So now I have x minus 4 in the numerator and denominator, so I can cancel those out, leaving me with z over negative z squared. All right, so that negative 1 I just took and multiplied with my z squared. So you can just write that out front of your fraction. And now remember, this really means we have z over z times z. So these will cancel. We need a placeholder in our numerator, so we still have 1 over z. And that would be our final answer here. So our answer would be negative 1 over z.